All right. Yep. All right. Cool. Well, thanks everybody for joining us. I'm Paul, head of community for Data on Kubernetes community. Excited for our October Data on Kubernetes Town Hall. Let me pull up my slides before I introduce our guests here. So, all right. So you're here today for our town hall with. Oh, I'm so sorry, Michael. I messed up the slide. All right, it's Michael Levan, not Florian, who was here a couple days ago. But he's going to be talking about AI and ML on Kubernetes for absolute beginners. And then we also have guest Neylson Crepalde, Crepalde, sorry, who will be talking about his book, Big Data on Kubernetes. So first, I want to thank our community sponsors. So our gold sponsors, Google Cloud and Percona. Thanks for sponsorship. We appreciate that. Also, we have our silver sponsors and our community collaborators. So thank you to them for allowing us to do these types of events we're doing right now. I want to make an announcement about Data on Kubernetes Day at KubeCon North America, which of course is happening next month in Salt Lake City. November 12th is DoK Day, which is a co-located event with KubeCon. Schedule's out. You can see the schedule if you scan the QR code. You do need an all access pass to be able to attend. So if you haven't done that already, get your all access pass and come visit us at Data on Kubernetes Day. And I want to give a thank you to our event gold sponsor, Percona. Also, KubeCon EU in 2025, the CFP is open for KubeCon. So this is not DoK Day. This is just for KubeCon through November 24th. And you can submit your proposal if you scan the QR code there on the right. Now, also, big announcement is that we just found out we will be back for Data on Kubernetes Day at KubeCon EU 2025. So stay tuned for more information. It's going to be coming soon. So we'll also be opening up the CFP pretty soon. So if you've got your DoK talks, get them ready. But stay tuned for more information. I just want to highlight one of the projects we're working on the DoK SIG is the Get Started project. So it's a community collaboration project trying to make it easier for people to get started running data workloads on Kubernetes. So I want to give a special thank you to the contributors so far, Ryan Wallner, Jonathan Battiato, Steve Sklar, and Khalil Princewell. So you can actually contribute to that if you scan the QR code there. That'll take you to the DoK GitHub page, and we have a Get Started project. And you can submit a pull request if you have information you want to provide to the community. If you want to get involved in the community, you can scan the QR code on the left. I know tons of QR codes. That'll take you to our community page. If you're interested in sponsoring the community, scan that QR code on the right. Yeah, we're always looking for people to join the community. So hopefully, since you're here, hopefully you want to be a part of that. Also, if you stay to the end, you can win a copy of Neylson's book, Big Data on Kubernetes. We're giving away 2 hard copies and 1 digital copy. So thanks to Neylson for providing those. That's the book. You can win it. So that'll be at the end though, so you can stay till the end. But for now, I will hand things over to Michael, who will do his presentation.
Thank you so much. Appreciate it. And hello, everybody. Good morning, good afternoon, good evening, maybe, wherever you are in the world. I'm going to be talking about all things ML, and I'm sure the whole AI thing will end up coming up as well here. So what I'm going to do is I'm going to show a PowerPoint, and then I'm also going to show a little bit of hands-on. So the goal is I want to get through some theory, and then I'll show the whole installation and configuration process for Kubeflow, which is a way to run machine learning workloads on Kubernetes. Okay, so again, a little bit of PowerPoint, a little bit of hands-on. The reason why is because I always want to make sure that I give the why and the how behind everything. You can't understand the why fully until your hands are on the keyboard, and you can't understand what you're doing with your hands on the keyboard unless you understand the why behind it, right? So let's start with the PowerPoint piece here. I'll go ahead and share that. All right. So AI, ML, everything for Kubernetes. What does it kind of look like? How do we do it today? How do we run our workloads? All that jazz. So, excuse me, I got a little something going on in my throat today. My name is Michael Levan. I'm a distinguished engineer at a software company called Kodiak. I've published a ton of books. I think I'm on number 4 or 5 at this point. Public speaking engagements, so stuff like this, stuff on stage. If you're in California, I'll be speaking at SRE Day, November 8th. And then I'll also be at KubeCon if you want to chat. And I also do a ton of content, so blogs, videos, podcasts, all that jazz. So really quick, diving into the ML terminology piece here. And I want to just also bring something up that I didn't put into these slides, but I think it's really important to talk about. I spent a significant amount of time over the weekend and the past couple days. It's Thursday, so I mean last weekend. I don't really know what day it is at this point. I spent a lot of time with GPUs on Kubernetes and GPUs on containers, primarily NVIDIA. There's also ways to do it with AMD and with Intel graphics and such, but I'm definitely seeing more of a demand in like the NVIDIA space. I didn't think just for whatever reason they are winning the graphical wars. And I think that it's always kind of been that way, just going back 10 plus years ago when I got into PC gaming and stuff. It was always like NVIDIA over AMD. The graphics were always just better. The cards were always just of better quality, etc. And I'm not saying one is better than the other. I personally have used both, and I never saw that large of a difference. But it's good to just point out that this whole GPU thing on Kubernetes, on containers, is an actual thing. All right, so what is ML terminology? What should you be thinking about as somebody in the DevOps space, in the cloud native space? Um, how does this kind of like relate to what you're doing? Well, it's all going to come down to the organizations that you're working for. So the way that I'm seeing it, organizations are bringing in ML and AI stuff for a couple of different reasons. Number one, they're bringing it in because they're an AI organization that's trying to get to maybe some type of like general intelligence, right? Like we're seeing all like the Microsoft stuff and the OpenAI stuff. They're putting like $100 billion into this super data center computer thing, supercomputer stuff that maybe should be up by 2027, and it's uh, five 5 gigawatts. I think I'm getting that correct, which is enough power to power New York City. Yes, that's 100% true. It's pretty crazy. So that's going to be the energy and the electric that's going into this supercomputer data center. And the goal with that is to get to general intelligence. Right now, the furthest we've been able to get is LLMs, right? Large language models, which is not general intelligence. It's like lower level intelligence. It goes lower level and then general and then super. We've never gone to general and super yet. These are just it's all theory right now. But general and super intelligence, that's when we get to things like, hey, these Tesla robots are learning for themselves and thinking for themselves, and we don't have to give them data. They're just kind of learning it on their own. That's general and super intelligence. So that's one type. The other type is, the general AI companies that are trying to do stuff with ChatGPT in the back end or GPT-4, whatever you want to call it. So for example, you see a lot of vendors right now saying, yeah, we're bringing in AI to do this and to do that. And generally it's GPT or GPT-4 on the back end. Okay. Uh, the third type, I would say, if you're trying to implement machine learning for data science needs, or even just machine learning for forecasting. Like I know there are a lot of companies out there right now that are trying to do forecasted resource optimization. So like, let's say, for example, you're an e-commerce website and Cyber Mondays are super, super big for you. Well, excuse me, you know that you're going to need to upscale on Cyber Mondays, right? But the next Cyber Monday, you're going to have to upscale, but there's also maybe a 10% increase in traffic in your company because your company has hopefully grown. So the idea behind the ML forecasting is essentially to be able to tell you, hey, you should increase your Kubernetes clusters or your worker nodes for CPU and memory by this much based on our calculations. So those are the three that I think I'm seeing right now. And because of that, even if your background is in DevOps engineering, platform, SRE, cloud, whatever, you should still understand this terminology a little bit. So, oh, and by the way, if you have any questions, please feel free to ask them as we're going through. I don't know if I can personally see the questions, but I'm sure somebody will let me know if a question comes in. So we'll keep things brief, just 5 pieces of terminology that you should really be thinking about. First, models. And models are a collection of data, okay? So it's essentially a collection of data sets, right? What's a data set? A data set could literally be anything from an Excel spreadsheet with 5 rows and columns in it to large medical files. You take all those data sets, you train them into models. Those models are then trained to do whatever needs to happen on the back end, train your AI or train your LLMs or whatever. The model registry, that's where these things are stored. Think about it like a container registry. Like you build a container image and you store it in Docker Hub or wherever. You build a model and you put it into a model registry. Auto ML, this is the automated process of training models. If you're not, a data engineer or a data scientist or somebody that's purely doing model training. So it's essentially if you need to do model training, but you're not an expert, okay? Notes, think of these like Jupyter notebooks in a sense. It's kind of like an IDE where you can write your code and run it in a terminal-based style environment. Jupyter Notebooks is great as well because you can essentially write up like a whole doc with code examples in it, and you can step through them. So you can run piece by piece, which is really nice. And then pipelines, I like to think about it like a CI/CD pipeline, right? It's just automated workflows for your model building process. So I don't know if anybody else, like the data scientists and everybody, are saying like, this is like a CI/CD pipeline, this is like a container registry. Probably not. I'm just giving you these mappings just for it to make a little bit more sense in your head when we're talking about the terminology. Okay, so what's Kubeflow? Well, Kubeflow is a couple of things. Number one, there are a lot of tools in it that already exist: TensorFlow, PyTorch, Jupyter Notebooks, etc. But then they're also building out their own tools to make things a little bit easier, right? Like their training operator is, like a standard Kubernetes operator, just extending the API base and putting in controllers and such. Pipelines, which again we talked about, are for workflows and schedules and such. You have your central Kubeflow dashboard. And the whole idea here is that, and this is my take on it, I don't know how in practice this is right now, but here's the thing. We're building these super data centers, which are billions of dollars. Tesla built one that was a couple $1 billion. Microsoft and OpenAI are building one currently that, again, in 2027, they've invested $100 billion into it. So this is a lot of money we're talking about, okay? Now, why do we need all this money? Well, servers are expensive and data centers are expensive and power is expensive and HVAC for the air conditioning is expensive and all these things are expensive and GPUs are expensive as well. This is I was testing out some stuff on GCP over the weekend for GPUs on GKE, and the one GPU that I was looking at, I think it was H100, NVIDIA H100, I want to say. But for me to run it in GKE, it was like $143,000 a month. Okay. So, and I think I put the screenshot on Twitter or X. You can go take a look at that. Yeah, but like, so these GPU things are pretty expensive, right? Now, why is containerization and Kubernetes so powerful? Well, the idea of decoupling our workloads. That's why we went from, computers that were the size of a room to refrigerator-sized computers that are like a mainframe to servers to virtualization to containers, right? Like we keep getting smaller in hopes of having the same performance. So the idea here, in my opinion, is if we can use something like Kubeflow, run our model training on Kubernetes, have shared GPUs, we might be able to cut costs down a decent amount. We might be able to scale way more. And we could do that right now. Like you could run GPUs on Kubernetes. You can run GPUs in just standard containers. So let's say you're using container D or CRIO or Docker, whatever for your container engine, you could point the GPU drivers to that container engine. So we can do these things right now. And the goal here, again, with Kubeflow, with GPUs on containers and GPUs on Kubernetes, is the ability to say, hey, we want to be able to lower costs. We want to be able to lower overhead. We want uh, smaller data centers. We want less servers. And I think that's a pretty good goal that we can all kind of get to if we're contributing to the ML and AI stuff and all that. So I think companies can definitely get us there for sure. All right, so what I want to do is I'm going to pop over to VS Code and we're going to get a little bit hands-on, right? So if you go to my GitHub, it's just admin turn DevOps. That's the org. And then if you go to Kubernetes and production examples, you'll be able to see this AI and ML folder. And then under Kubeflow, you can see these instructions. So you could do the same thing on your end. All right. So you're going to want to bring down the Kubeflow manifest. You're going to want to CD into the directory and then check out either the beta or alpha branch or the prod branch. Okay. So the manifests, look like any other manifest, right? It's all customized underneath the hood and it's all Kubernetes manifests. And we don't have to look at all that YAML because YAML is not fun to look at. But the gist is it's a huge project. Like there's a lot of components that you need to get all of Kubeflow up and running. You can also do standalone options, but even with the standalone options, like it's not one container image. Like you have to get other pieces of the puzzle up and running as well. So all in all, it is a pretty big system, and we'll see that in a second. So what I'm going to do is I'm going to run this command. Essentially, the reason why I have to run this while loop here is because there are definitely a couple of race conditions in here, as in, things come up before other things, and those things have dependencies on those other things. So we pretty much just have to keep looping through this kubectl apply until the pods are up and running. And this is common. Race conditions are common in Kubernetes just because one container or pod comes up, another one doesn't. There's a prerequisite there. There's a dependency needed. So got to run some while loop sometimes. All right, so we're going to go ahead and we're going to run that. Now, for all this to finish, because again, it's a fairly large system, it could take a couple of minutes, maybe 5 minutes. The Azure cluster that I'm running on is pretty beefy. I'm going to talk about prerequisites in a second here. So it should be decent enough in terms of speed. All right. So I'm going to kick back to the PowerPoint. That way, nobody's just sitting around looking at my face for 5 to 10 minutes. And I also want to see, are there any questions, anything that I can answer? Sometimes I talk a little bit quick when I get excited, and I'm definitely excited about this topic. So I wanted to just see if there are any questions or anything that I can help answer.
No, there are no questions yet, Michael,
Okay.
but I feel like the questions tend to come. I feel like once once you get going. So,
Sure.
but yeah, just a reminder, everybody, like, don't be shy. Any questions you have, like, we want to hear them. Pass them on to Michael.
Yeah, totally. Okay, so what are the tools in Kubeflow outside of Kubeflow? Or rather, tools that you could maybe use with Kubeflow, or if you don't want to use Kubeflow. The first, MLflow. The second, TensorFlow. It is part of the Kubeflow system, but if you want to use it separately, you can. And then there's something called Ray. I think for Kubernetes specifically, it's called Kube-Ray. And then there's also something called deploy.kf. I don't know the status of that project. I haven't looked at it in a long time, but essentially it's Kubeflow underneath the hood. It's just giving you a little bit of an abstraction on top, which is helpful because Kubeflow could be a little bit cumbersome to get up and running and configured and all that good stuff. So that's a fourth one I didn't put on here because I haven't looked at the project in a while, so I didn't want to say, hey, it's up and running and it's not. I don't know. I'm assuming it is, but yeah. Okay, so how does Kubeflow and Kubernetes help each other? Well, we kind of talked about all this stuff a little bit, right? But let's break this down more. So here are integrations for Kubeflow. We're going to see a ton of different things that, we kind of already maybe know a little bit about. PyTorch, TensorFlow. These are tools that have been around for a long time. They're not Kubeflow specific, but there are a lot of integrations when it comes to Kubeflow and these tools. Now, when we're talking about the Kubeflow components, we have the pipelines, we have the notebooks, we have the dashboard, we have the training operator, Kserve, all these things that we talked about already. We also have some external add-ons here. And then we get to the infrastructure layer, okay? So things like Cert Manager to make sure that SSL is working as SSL does for communication and for encryption. Kubernetes, of course, that's our orchestration layer until it isn't anymore, which, we got a little bit of time left on Kubernetes before the next thing is popping out, I would say. Istio, right, for our service mesh. And then we have our infrastructure. So again, I want to stress that right now this is running on Kubernetes and Kubeflow is Kubernetes specific, but underneath the hood, wherever Kubernetes is running, AWS, GCP, on-prem, micro-K8s on your local computer, shouldn't matter. Just understand that it's running on Kubernetes. And then the hardware. So NVIDIA, Intel, AMD, whoever are producing GPUs. Now, I haven't seen anybody else producing GPUs in terms of like an up and coming company that is going to take down AMD or take down NVIDIA or something like that. But look, it's possible, especially right now. Like somebody may be cooking something up in their basement as we speak. That's 20 times more powerful than NVIDIA and AMD, and three-quarters of the cost. Yeah, we really don't know, right? But this is the overall stack and the overall ecosystem. And as you can see, I mean, there's there's a lot of complexity here. We're outside of Kubeflow. I mean, just Istio alone, right, could be rather complex to configure. Your cloud infrastructure could be rather complex to configure. So this is a big job. This is not something that you're going to get implemented and done in a day. Okay. Okay, so Kubeflow, you have everything that you need for ML training, the data preparation, model training, experiments and runs, predictions, serving, pipelines, the ability to test and write your code with notebooks if you want to. Okay, and hardware prerequisites, okay? Kubernetes version 1.27 or above. 32 gigs of RAM spread across your cluster, not per node. So if you have 4 worker nodes, just make sure it should have at least 32 gigs of memory or RAM, and 16 CPU cores, again, spread across the cluster, not per worker node, spread across the cluster. I think I got a question that maybe came in. Why is Istio needed for Kubeflow? Good question. I am going to share with you the why, because we're pretty much at the end of the slides anyways. So let me go ahead and pop this up because Kubeflow is still installing, so we got a little bit of time anyways. Istio Kubeflow. Let's go ahead and pull this up. All right. The docs are actually pretty solid. All right. But as you can see here, right, the gist, securing service to service communication, applying any access control layers. When you're using Istio, you can also rate traffic, right? So with service mesh, a lot of people just kind of go to it for the service to service communication, but there are a lot of network protocols that you can utilize for like QoS and understanding your network traffic and your bandwidth and the quality of that traffic through service mesh. So I would actually say that the networking piece from that quality and traffic perspective is a much bigger component in comparison to the service to service encryption. But essentially the reasons why you would want to use Istio, like in general, are the reasons why Kubeflow is utilizing it underneath the hood. And even if you say, hey, Mike, I don't need any of this stuff. I don't really care. It's a prerequisite, so we have to care. Luckily though, even though you have to care, once it's installed, like as in once Istio is installed with Kubeflow, you don't have to do anything with Istio. Like you don't have to be a service mesh expert or an Istio expert. It's just needed underneath the hood as a prerequisite. Yeah, good question. Let me see where we're at here. Couple of things are still installing. So does anybody have any other questions for me? Let me see something really quick. Oh,
I have a question.
yeah,
So what are like the resource requirements for running Kubeflow?
yeah, good question. Let me pull that up here really quick. I think I did an oopsies on my end here, so I am just going to quickly rerun the installation here. Pull this up here really quick. Oh, give me one sec. I'm just pulling up your question here.
Yeah, no worries. Take your time.
Where is it? There's a certain piece here. I'm gonna pull back up the slide because I was showing it in the slide, but there's something else that I would like to show you. So in this slide, like these are the general requirements, version 1.27 or above, 32 gigs of RAM spread across the entire cluster, and 16 CPU cores spread across the entire cluster. But one other thing I want to show as well, and it doesn't fit in a PowerPoint too good, so I want to show the documentation. Number one, outside of if you don't want to install Kubeflow, like I was saying, you can do piece by piece. But the other requirements that are big are from a platform perspective. So where you're running it. Okay. So the installation that I showed was if you want to run it in any environment. So what I showed, you could literally do in any environment, AWS, Azure, GCP, on-prem, doesn't matter. But there are also different ways from like a target perspective in terms of the platform. So AWS, if you're just running directly on Ubuntu, IBM Cloud, Azure, VMware, Red Hat, wherever, there are particular instances of platform. Now, do you need it? I, I think it depends on exactly what you want to do. So like if we go to the AWS one, for example, and I go to deployment options, you'll see here that they specify, are you running RDS, right, for your database backend? Are you using S3 for storage? Do you want to use RDS and S3 together? Cognito, RDS and S3. So there are instances where, like, if you have a specific classification that you're trying to run a specific application stack and you're using RDS, you're using S3, yes, those requirements are going to matter. But again, totally depends on how you're running it. And then another requirement to answer your question, and I'm dragging this out a little bit because I'm looking to my left and waiting for everything to be deployed. It looks like I actually did it right this time. Uh, there's also the development branch and the production branch. Okay, so dev branches, as always, if you want the latest and greatest, you could use a dev branch. If you want the production branch where you're like, I think things are working pretty well here, you can utilize that branch. Hopefully that answers your question. But yeah, hardware requirements, platform requirements, and what if you want to be, in alpha or beta or full production.
Sure.
And look at that. I talked long enough for the environment to come up.
You're welcome.
Thank you. So everything's up and running. We're looking good here. Okay. So what I'm going to do now is I am going to do a port forward here. As you can see, something else that Kubeflow uses underneath the hood is Istio's gateway. All right. So I'm going to go ahead. I'm going to pull this up. Let me just pull up a web browser here really quick. All right. Okay, and we're going to log in. This is the DEX is the, OIDC provider or authentication authorization provider, whatever you want to call it, that it's using on the back end, that Kubeflow is using on the back end. Password is just 1234 1234 to get in here. right? And Kubeflow is up and running. We have a couple more minutes left, which is awesome because I also want to show you how to get a pipeline running. Now, I'm not using a $100,000 per month cluster, so I'm not going to do any type of serious modeling here. But what I'll do is I'll do a custom model. Now, what I'm going to do is I'm going to go to pipelines. And I'm going to go to, I think some stuff is still popping up here in the back and I can see, yeah, Kubeflow takes a little bit to get up and running fully. But what we could do is you can specify a pipeline. I'm going to show you how I create this pipeline in a second. And then I can go to upload file. And I'm just going to, you probably can't see what I'm doing here. I'm just pointing to my pipeline. Give me one sec. I'm going to show you what this pipeline looks like in a second. I just have to find it here. Okay, cool. I'll show you what that looks like in a second. I'll switch back over to VS Code. And then we click create. All right. And it goes through and it starts to create our model that's going to be trained. The pipeline is the model that's being trained for us automatically. Now, what does that look like? I'm going to zoom out here for a sec. This is what our pipeline looks like, right? So this is essentially just uh, creating what a model needs based on what we want to be able to train. Okay. You don't really need to know this inside and out all that much. What you need to know is how to create that pipeline. Okay. So I'm using the KFP project Kubeflow, and I'm importing DSL. Notice here I have some generator functions. If you're not familiar with generator functions are essentially just adds functionality to your function that you're creating without you having to create more functions. So I'm pretty much just importing functions here, and I'm utilizing these functions in the function that I'm creating. Okay. And this is really simple, right? Literally just this is the hello world of data modeling. Okay. Let me see how this is doing. Okay, perfect. Yep, I can go in, see my pipeline. Let me switch back over. All right. So this is what our pipeline looks like. We can go to our runs. We can create a run based on our pipeline. What do I mean by create a run? Like I was talking about in the PowerPoint, when you have a data model, use a pipeline to automatically and continuously train that model for you. So what we're doing is I created a model, or created a pipeline that essentially said, keep training Hello World for me, that obviously doesn't have any like real world use case. But that's the way you could do it in a smaller cluster if you just want to get a good understanding of the way models work, how you can create a model, how you can create a pipeline, pass it into Kubeflow, and get all that up and running. One thing as well, I will create an experiment. The experiment is going to be the thing that's going to run the model, run the pipeline, rather. Okay. Just got to point it to the pipeline. And the parameter here, this is going to be what literally like your code parameters, like what you're supposed to pass in at runtime for the code that you're building inside of your function. Same thing here. So just literally since it's hello world, right? We'll do that. And then that's going to go through and notice here how the experiment automatically creates a run for us. And then the run finishes. This is going to fail. And the reason why is because I haven't actually figured this out yet. But notice how it says it's still running, but it is actually failing out for whatever reason. When the experiment creates the run for you automatically, it fails for me. I don't know why. If you do it just by itself, like if you create the run by itself, it'll be fine. So yeah, super strange. I don't know why. I don't know if it's a bug or I don't know if it's something with my pipeline, but yeah. So if you just rerun it again, you'll be good. So if you want to do what I did, go to this Git repo in admin turn DevOps org. I have the instructions here for getting any kube environment up and running. And then I have the instructions here for getting this done and spitting out the pipeline for you. The pipeline's already in the repo, but just so you could learn how to do it, I recommend just going through these anyways. And I also wrote a blog post about it if you want something a little bit more in depth. And that is me on time. So if anybody has any questions, happy to answer.
Yeah, and by the way, I'll pop in here too. We can, if you want to share those links with me, I can put them in
Oh
the
yeah,
description of the video.
for sure.
Um, that way, if people are watching this later, they can also access those.
Totally.
There was one question from SR. So said, so what are interesting projects based out of Kubeflow for infrastructure platform optimization?
I'm sorry, can you ask me that one again?
So it says, what are interesting projects based out of Kubeflow for infrastructure platform optimization?
Yeah, good question. So I'm assuming that question is geared towards like, is there anybody using them for like supercomputers or anything right now, or like bigger organizations training AI and ML workloads? The biggest one right now is OpenAI. So OpenAI actually uses Kubernetes underneath the hood to do all this stuff. I would say that's the biggest project right now. Any other like enterprise level company like that, I don't know of any that are currently doing it. I could totally be wrong there. I just don't know off the top of my head. Yeah.
Got it. Let's see. Ooh, I had one more question here about scaling. Now I just have to find
Yeah.
where I, where I wrote it down. Um, oh geez, now I can't find my own question.
Don't worry.
Um, one second here. Okay. Oh yeah. So like, what's your strategy for scaling Kubeflow as workloads grow?
Yeah, good question. So I would say think about scaling from like, you know how like we're thinking about resource optimization and cost optimization now. Um, the good thing about resource optimization right now is like with general application stacks, let's say, you know, you have 3 worker nodes running and you know you're going to need 4 running, or you know that you'll reach a point where like I need to scale up a node, or I need to put limits and requests on my current workloads. That works with application stacks that are scaling up slowly. But when we're talking about training models, I mean, this thing can go 0 to 100 incredibly quick. Like we need the ability to uh, scale fast, really fast, probably faster than like what Carpenter can even do right now. And I would say the best way to do that is have some hot cold clusters, or have some hot clusters, or just almost not care about the clusters. Like I'm a firm believer that Kubernetes clusters should be ephemeral and disposable. They should just be able to go up and go down whenever, and that's very much needed when you're doing something like training models. Like one example I can show you is what I'm doing in Kodiak right now. One of the things that I'm doing in Kodiak right now is I have Olama running, right, which is like an LLM. And the gist is the reason why I want to run it in Kodiak is because regardless of however I need to scale up and scale down, we do a lot of blue-green deployments. So if you're familiar with blue-green deployments and canary deployments and stuff, we're taking that same approach, except we're doing it with clusters to be able to scale up and scale down and do resource optimization very quickly for AI and ML workloads. So that's the product that I'm building. So I'll be cheeky and say give it a shot. But there's a ton of different ways that you can do resource optimization and all that for Kubernetes and for Kubeflow and ML and all that stuff. Just remember, like these workloads will scale very, very quickly. So you need to have something in the back end that it can help you scale fast like that.
Cool. Well, so there's one more question here from Chris who said, why would someone use Kubeflow over OpenAI's services?
Uh, my question back, sorry, I hate to answer a question with a question, but my question would be, what exact services are you talking about? because I'm fairly certain they're using Kubeflow. And if they're not, they're using another way to obviously run AI services and ML services on Kubernetes. Sorry, I just don't know what service you're referring to, Chris.
Sure.
But if you don't answer that, if you can't answer that question now, just feel free to ping me on LinkedIn or something, and follow up.
Yeah, and then I guess Chris had another question. Says, does Kubeflow work across clusters?
Meaning, can you have a I'm assuming he means like, can you have a central cluster, like a management cluster, and register your other clusters with Kubeflow? I'm 99% sure the answer is no, not at this time.
Okay, cool. Well, yeah. So if you have more questions, we gotta move on to our next speaker. But if you have questions, yeah, reach out to Michael on LinkedIn. I'm sure he's willing to answer your questions. Uh,
Absolutely.
Michael, thank you so much. Really appreciate your time. That was great, super informative, and a really hot topic right now. So it's great to have you on.
Absolutely. Thank you so much. Really appreciate it. And thank you everybody for listening to me babble for 30 minutes. Appreciate it.
All right, cool. Well, Neylson, you are up. So let me introduce Neylson Crepalde, who's just put out a book called Big Data on Kubernetes, a practical guide to building efficient and scalable data solutions. So, Neylson, go take it away and talk about your book.
Yeah, awesome, Paul. Thank you for inviting me. Hey, everyone. Thanks for joining us on this nice discussion. I was really impressed on Michael's presentations, and actually, Kubeflow is the one topic that I didn't write about in the book. This would be a nice complement to our content, right? But anyway, guys. So again, thanks for joining. I'm Neylson Crepalde. I'm based in Brazil, in São Paulo, and I recently published this book called Big Data on Kubernetes. Big Data on Kubernetes, it is an attempt of basically explaining complex concepts in a very simple and practical way. Subtitle says a practical guide to building big data workflows on top of Kubernetes. It all started when I was CTO at a consulting company in Brazil a few months ago. And then what my team and I tried to do was to get our big data architecture to run on Kubernetes. Like 3-4 years ago, we had some challenges regarding cloud costs and scalability, reliability of services. Whenever we had a service or data engineering tool that was not working, that was a real pain to debug, to fix. It took sometimes like several days for the DevOps team or the IT team to fix everything, and the data team goes back on track on working. And this was starting to become a real pain for the market. We had a lot of customers across several industries in the market back then. And what we were thinking about, was there a way of having our big data stack? Today, I think we call that the modern data stack. We have several services. For example, if we think about a Lambda architecture, when we have a batch processing layer and a speed layer for real-time data processing. On a batch layer, we would have tools like Spark for data processing and Trino for data serving and Airflow for batch pipelines building and orchestration and those kind of stuff. And in the speed layer or the real-time layer, we would have services like Kafka, like Spark, again, doing real-time data processing, like OpenSearch or Elasticsearch or MongoDB for real-time data serving, Superset as a nice analytics tool, for example. So we try to think about, is there a way that we could have those services running in a very reliable way that they could get together from recover automatically from failure, but also scale automatically and be easy to deploy and easy to configure and change updates and change scale or anything like that? And the answer that we found back then was Kubernetes. Yeah, Kubernetes 4 years ago was a technology that was starting to get well known among developers, but not so well known among data teams. I think this is the whole idea of the community anyway. I started following up the discussions on this like at that time 4 years ago ish. But anyway, so what happened was that we put together a team of our best specialists back then, our data architects and our most senior data engineers, and we started working on a Kubernetes-based version of our big data architecture. So we had this Lambda architecture for a data lake that was the basic data architecture of any company in the market back then. Obviously, we have some variations today. We have data mesh with a different approach. Now we mainly work with data lakehouse, a new version that provides some nice features that we had when we worked with data warehouses, but now in a data lake infrastructure. But basically, we wanted to run everything on Kubernetes to facilitate for scalability, for reliability, and also to have this architecture almost like a data product. We didn't want every instantiation, every time that we had a project with a customer for a data lake implementation, we didn't want to do everything from scratch. Although we work with Terraform, with lots of automations back then, but when you have it on Kubernetes, it's really easy to build your manifest and your modules and put everything together really fast. Before we had our Kubernetes-based big data architecture, it usually took 2 to 3 months for a complete full deployment of the big data architecture that we had. And after Kubernetes, it took roughly 1 week, 5 to 7 business days. So it was a big improvement in time. We had a lot of improvement also in scalability, also in reliability. But a really nice to have surprise was that we increased a lot for cost efficiency in our customers. Usually, when you build your big data stack, your big data services and tools on top of Kubernetes, when you deploy them on Kubernetes, you get a ton of cost efficiency, costs a lot less than if you would rely only on cloud services. But anyway, so we put together this team 4 years ago and worked for 1 year building piece by piece this architecture. And we worked for almost a year. And at the end of this timeline, we had the first version of our architecture. We tested it internally as much as we could, almost exhausted, almost to the exhausting. And we started working with some customers that had some maturity with Kubernetes that were ready enough to have this kind of architecture running in production back then. And the results were just amazing. We had 5, 6, then later almost 10 customers using this architecture on production fully with everything that they need, monitoring, automatic scaling, everything. It was pretty great. Then, this is the story of how it began, and then we started writing a lot about it and talking to other customers and teaching other people on how we built this architecture, especially because this is funny because a Kubernetes-based big data architecture isn't actually for everyone, because I heard a sentence a few years ago, and I totally agree with it, that Kubernetes is a beast to get started. And I agree with that. That's one of the reasons I wrote this book, actually, because it's really tough to get started. It has some complex concepts. It's not the easiest thing in the world to handle, especially when you have problems, when you have to debug, when you have to fix things. But once you get started, once you get to know the concepts, and once you okay, this is how it works. This is how we debug. This is how we fix. It tends to get easier, but for a production enterprise level environment, you should have a team who knows the least about Kubernetes, so you won't get in trouble. Yeah. So this is so yeah. Do you have questions
Oh
so
yeah,
far?
I was just gonna say, was it difficult to convince those, first set of customers to do this approach?
Well, not actually, Paul, because again, it's not for everyone. So we were very carefully, we were very careful back then to whom we would suggest this kind of architecture. We will not suggest, for example, if the customer told us that, oh, we don't have an expert team of DevOps, of Kubernetes people, we don't have that skill, we don't have the knowledge inside the company, there was no point of offering them that as value. There was no value for them. But if they said, hey, we have a team that understands about Kubernetes and we spend like X amount of X $1,000 on data services right now. Okay, do you have spend like half or less than half than that? Let's try to build it on top of Kubernetes. And when we showed the cost calculation, it was like almost instant, there's a lot of work, there's a lot of debugging, you have to maintain it. But anyway, when you see the scalability and especially the reliability that Kubernetes offers for those kind of big data tools, it's amazing. It's amazing, and for much, much lower costs. So it was not so difficult conversations, actually.
Sure. Well, now you have the proof is in the pudding, right? So now you can show those cost savings, and that's probably very attractive to a lot of people.
Exactly. We were able to reduce the costs in some cases for half, and some other cases when we had some optimizations to do, even more than half, like more than 50% cost reduction. This is amazing for the companies.
Wow. Yeah. Cool. Thanks.
Awesome, awesome. And then, so this is why we started. Then this architecture went on track and went to production on several of our customers. And then we started try to spread the word about it and tell everybody and teach a few people. I have been a college professor for more than 10 years now. And I used to run an MBA program on data engineering, and we kind of shifted at a certain point this MBA program and started teaching the big data tools on top of Kubernetes because we saw that there was a growing demand for that skill in the market. There is a growing demand for that skill in the market, actually. A lot of cloud services have their data services now running on their flavors of Kubernetes. I know AWS has a service like that, has EMR on EKS, which is a very nice service, by the way. And then we started producing a lot of content and a lot of educational material for teaching people how to get started with this, especially because data teams were not used to Kubernetes as developers. So it took us data people a while to understand about Docker, about containerizing our workloads, about the Kubernetes and that. And we were trying to help them get acquainted with that knowledge as soon as possible because there was high demand in the market. And then one day I received an invitation from Pack Publishing. Yeah, hey, we have an idea. We saw your content, and we would love if you wrote a book called Big Data on Kubernetes. And I said, well, this is a very nice idea. I mean, I don't know if I'm crazy about how the amount of work involved on writing this book, but hey, let's do it. And then we spent something like 8 months writing the book. Basically, the book is structured. This is supposed to be a very didactical, very practical book. It's not super dense or super specialized, and we didn't have space to treat on detail on every service that we are approaching. My main goal on writing the book was providing a place to start for every data team that wants to work with Kubernetes. So we have a first part of the book that deals with containers, Docker, mainly some important concepts on Kubernetes and how to build your first like small workloads. I give an example of having an API and a job run on top of Kubernetes. Then we go back to the data stack, and I introduce the main technologies that we use on big data right now. We have a chapter on Spark, a chapter on Airflow, a chapter on Kafka, the main technologies that we use for that. One chapter, if I'm not mistaken, on data data serving. We use mainly Elasticsearch, Trino for that. Those are the two services that I'm teaching on the book. And then we have a third part of the book that's called Putting It All Together. So I teach how to deploy those tools on top of Kubernetes, how to deploy the last part, that is the data serving layer on Trino and Elasticsearch. And chapter 10, which is the 3 down to go, is where we do two projects, one batch processing project and one real-time project. By the way, every chapter on the book, you will have several exercises, small projects to do. The idea is to be very practical and provide the readers with exercises to get acquainted to that. So in chapter 10, we have these two main. This is the top of the mountain for the book, where we connect everything together. So we have an entire batch processing pipeline running on Kubernetes with Airflow, data processing on Spark, and using Trino for serving this to a dashboard, for example. And on the real-time layer, we have Kafka as a broker for events. We have real-time data processing with Spark structured streaming. And we have real-time data serving in a nice dashboard with Elasticsearch and Kibana. And we have a plus. We've started to working with GenAI. And GenAI, as you all know, is a hot topic. It's on high demand everywhere. And so we had the idea of writing one more chapter, that's chapter 11 in the book, called GenAI and Kubernetes. So mainly when you have to build a GenAI solution and host it on Kubernetes, that would be my first choice of deployment. How should I do it? And then I show how to connect with Bedrock service on AWS that offers a ton of LLM models for choice, and build a very simple UI on top of that using Streamlit, and how to deploy that on Kubernetes. And we end with chapter 12, mentioning a lot of stuff that we didn't have space to discuss on the book. That's about monitoring, auto scaling, plugin into, for example, Grafana, Prometheus, all those services that some security important things that would be very important for a production environment, but not for a beginner's point of view. So I just like have this final chapter on where to go from here, what's important for you to know, what's to reach out for information later. And that's it. I have been receiving some very, very nice, very gentle, very kind reviews because of the approach. It was intended to be a book that like almost anyone can read and understand and try. All the code is available for free online. It's on GitHub. I'm sending Paul you on the chat the link for the GitHub
Awesome.
repository with all the code that you have in the book. I have monthly updates on this code because, as you know, technology changes a lot and fast, and we have to keep updated. So I'm trying my best to keep everything updated and working for all of you to use it.
Awesome. Well, okay. Well, we have a couple questions, but I kind of feel like maybe the one question can't be answered very quickly, and we only have 1 minute left. But so maybe can people reach out to you on LinkedIn to ask additional questions?
Yeah, for sure. Please add me on LinkedIn. I just search for Neylson Crepalde. I'm the only one on LinkedIn with this very weird, strange name, so it's easy to find me.
Awesome. All right. And then one person asked, how do they get the physical book in Brazil without international shipping? Do you have a way?
Oh yeah, because like prices in Brazil are not so friendly. I know. reach out to me. I have some copies that I can sell it to you with the authors only price.
Cool. All right. Well, you may not even need that if you win this book. So let's last minute. Well, by the way, thank you so much, Neylson. Really appreciate your time. I think this book, it sounds like it comes from a lot of practical, a lot of probably a lot of work and a lot of practical knowledge that you learn from actually building stuff. So I think
Yeah.
it sounds like a really amazing resource. And before I also move on, thank you, Michael, again for your presentation as well. It was like super useful. I think a lot of people will get a lot out of it. So I'm going to share my screen. This is your opportunity. If you scan this QR code, it's going to take you to a form. All you need to do is put your name and your email address. 3 of you will win at least either a digital copy or we have 2 hard copies. So don't worry, I'm not going to take this information other than being able to contact you and give you a book. So fill the form out there. I'll leave it up for another few minutes here, and then we'll select randomly, and then I'll reach out to you within the next couple of days, and we'll work out how to get you those books. So yeah, I'll leave it up for like 20 more seconds or 10 more seconds. Yeah, this was really great. I think 2 really great talks. Again, just to reiterate, we'll be at KubeCon for Data on Kubernetes Day on November 12th. So you can come hear more information about Data on Kubernetes. If you're interested in joining the group, you can go to the DoK.community, go to the community page. There's lots of ways to get involved with Data on Kubernetes. Join our Slack. But yeah, if you have more questions for our 2 speakers, Michael Levan, Neylson Crepalde, and I know I didn't say the first name correctly, but yeah, so hopefully you all have checked out the form, filled it out, and we will I'll let you know if you won the book. Again, thank you everybody for being here. It was a great talk, and we'll catch you at the next one. Actually, just to announce, we will not be doing a town hall in November because of KubeCon. So the next one will be the following month. So, all right, thanks so much, everybody. Have a great day.